Hello everyone. I'm Dr. F. Nirmala, Assistant Professor of the Department of Mathematics, Nirmala College for Women, Coimbatore. In this video, I'm here to introduce to you a very simple and an interesting application of mathematics optimization techniques, specifically the formulation of a linear programming problem. Optimization is a way of life. We all have finite resources and time, and we want to make the most use of them. Starting from using our time productively to solve the supply chain problems, transportation problems, allocation problems, and many other, everything involves optimization. Linear programming is one of the simplest ways to perform optimization. It helps us solve some very complex optimization problems by making a few simplifying assumptions. What actually is linear programming problem? Linear programming is a simple technique where we reformulate the complex relationships through linear functions and then find the optimum solution or the desired output. Let us see an example. Let's say an Amazon delivery man has 6 packages to deliver in a day. The warehouse is located at point A. The 6 delivery destinations are given by U, V, W, X, Y, and Z. The numbers on the lines indicate the distance between the cities. The aim of the delivery person is to find the shortest route with the minimum transportation cost. Hence, the delivery person will calculate the different routes for going through all the 6 destinations and then come up with the shortest route. This technique of optimizing is objective pertaining to a given set of constraints is called as linear programming, a branch of operations research. Thus, operations research is an approach to decision making which involves a set of methods to operate a system. How to convert a real-time problem into a linear programming problem? This conversion involves 4 basic steps. The common terminologies used for the conversion are decision variables, objective function, constraints, and non-negativity restriction. To reframe the problem into a mathematical one, we have to first understand the root cause of the problem or the major factors that determine the problem. Mathematically, those factors are called as decision variables. The decision variables are the variables which will decide the output, which represents the ultimate solution. To solve any problem, we first need to identify the decision variables. The next step in the formulation process is the framing of the objective function, which can either be maximized or minimized as required. The objective function. The objective of a linear programming problem will be to maximize or to minimize the desired output. The objective function indicates how much of each variable contributes to the value to be optimized in the problem. The third part is to mathematically identify the constraints or conditions under which the objective function has to be optimized. The constraints. The constraints are the restrictions or limitations on the decision variables. They usually limit the value of the decision variables. Non-negativity restriction. For all linear programs, the decision variable should always take non-negative values, which means the values of the decision variables should be greater than or equal to 0. After all these steps, we would have successfully converted a real-time problem into a mathematical form by identifying the decision variables, writing the objective function with the mentioned constraints, explicitly stating the non-negativity restriction. For a problem to be a linear programming problem, the decision variables, objective function, and constraints all have to be linear function, and hence the name linear programming problem. Hope you have understood the concept and the basic terms needed for the solution of a linear programming problem. Thank you.